number 16, we're trying to solve this by using the elimination method for the systems of equations. And we see that we have fractions here. So everybody loves fractions. My first step is just going to be to actually eliminate the fractions. So before I do anything with the elimination method or the two equations together, I'm just looking at this equation and I want to get rid of the fractions. And we do that by multiplying by the LCD of these three fractions. The LCD of 6, 2, and 3 would be 6. So I'm multiplying everything here by 6. So the top equation is not changing. The bottom equation is going to be x minus 3y is equal to 2. So the 6 is going to cancel out with each of those fractions. So now we have our new system of equations, but we still need to worry about the elimination method. And I'm going to choose to get rid of my x's. If I add them up as they are, they're not going to go away because an x plus an x is 2x. So I need to make one of them negative. And I'm going to choose to make the top one negative. But you could choose to make the bottom one negative. Okay, so this will be negative x minus 2y is equal to 3. This will be x minus 3y is equal to 2 because I'm not changing the bottom equation. And when you add these up, you should get negative 5y is equal to 5, and divide both sides by negative 5, and y is equal to negative 1. So again, we had to multiply by 6 to get rid of the fractions, just one of the equations. Then we had to multiply one of the equations by negative 1 so that the elimination would work out. Now we have half of our answer, and I need to plug that back into one of the original equations. I'm not going to choose the fraction one because I don't want to, so I'm just going to plug it into the top one. So x plus 2y, but I know what y is. It's negative 1 is equal to negative 3. So x minus 2 is equal to negative 3, and x is equal to negative 1. So they're actually both negative 1. That can happen. And it does here. So that is the intersection point of these two lines.